So first of all, this is conjunctive. It's an and. And an and situation, or a greater than, is conjunctive. It's an and. That makes a difference in how you look at the solution to the problem, not in how you start it, but how you look at the solution. You start them in the same way, whether it's conjunctive or disjunctive. So we start out with 4 minus x over 5 is greater than or equal to 1, and that's the key, the connective word between them. 4 minus x over 5 is less than negative 1. So it's less than or equal to negative 1. So it's greater than or equal to 1 or less than or equal to negative 1. Multiply both sides by 5. Subtract 4. And when you're multiplying or dividing by a negative, you reverse the inequality. So we have x is less than or equal to negative 1. Solving the other inequality, multiply both sides by 5.
I think it's 4 minus x.
This is 4 minus x. Subtracting 4 and multiply and divide by a negative reverses the inequality. Now, because this is, I'm sorry, this is incorrect here also. This is an or situation between them, not an and. Okay, so we have an or situation because it's greater than or equal to. Less than or equal to is conjunctive or an and. So when I take a look at this solution, I'm saying from 9 to the right or from negative 1 to the left, inclusive of negative 1 and 9, is the solution. And I write it as negative 1, as negative infinity to negative 1, inclusive of negative 1, or is the U for union, 9 to infinity. Then that's going to give you a solution of negative 3. So that gives you two regions to test. We're either going to test to the right or to the left of negative 3. So let's test to the right. Let's test 0 in the original equation. So 0 minus 2, or negative 2, over 0 plus 3 is 3, is negative 2/3 less than 1. And it is. So this portion of the graph works. Let's try something on the other side of negative 3. Let's try negative 4. Negative 4 and negative 2 is negative 6. Negative 4 plus 3 is negative 1. And is 6 less than 1? No. So the region that works here is from negative 3 to the right. Let's take a look at the other one. I have x minus 2 over x plus 3, and now I'm going to add 1 to each side, and I'm going to add it as x plus 3 over x plus 3. Greater than 0. In the numerator, I have x plus x is 2x, negative 2 and 3 is positive 1, over x plus 3. Now that's going to give me two test points. Negative 3, same as I had before, by setting the denominator equal to 0, and negative 1/2 by setting the numerator equal to 0. So now I'm going to test in each of these three regions. To the right of -1/2, it's easiest if I just pick 0. 0 minus 2 is -2. 0 plus 3 is 3. Is -2/3 greater than -1? Yes. Let's try something between -3 and -2. Let's try -1/2 and -3. Let's try, for example, -1. -1 and -2 is -3. And -1 and 3 is 2. Is -3/2 greater than -1? No, that doesn't work. And let's try -4 in this region. -4 and -2 is -6. And -6 over -1 is +6. Is that greater than -1? Yes. So now we have to put these two together. We have to put the solution we have on the left and the solution we have on the right. So we have -3 and -1/2. On the left, what worked was from -3 to the right. What worked on the right was from -1/2 to the right and from -3 to the left. What we need to look at is what these two have in common. So we're going from here over that satisfy this one. And then here it's from -1/2 this way and from -3 this way. Where do they intersect or overlap each other? And it's only from -1/2 to infinity. So our solution is just -1/2 to infinity as a solution to the problem.